Okay, I think we can get started. I am Ricardo Virgilio. I've been working for the company for like 9 years now. I have developed most of the code that is in ExternalEvaluate. So, I mean, ExternalEvaluate is kind of an ambitious thing where, we have this new thing that are called external code cell, and you can write in any kind of language. So this example, for example, is using stable diffusion in order to, produce an image from a and you can see that basically, you run this code. I'm not doing it right now because on my machine it takes 15 minutes, but and an image is coming out. Because basically what this framework is doing is using the standard PIL image in Python, and so a Python image is coming out, and we know how to handle them, and we transform them into a Wolfram language image, and so you see it directly inside the notebook. So this is really making. I mean, the idea is that you can use notebook for every language with this kind of cell, much likely Jupyter notebooks, yeah, in some cases like this one works just really fine. So I know that people are using these things a lot, and I'm curious to know how you guys are using it. So again, in the workshop, feel free to come there and show me what you've got. In any case, as I was saying, we have a lot of ground to cover. So let's start with what we're going to do today. First thing is going to be SQL evaluators. Then I'm going to move to share evaluators. And then I'm going to talk a little bit about Julia improved type support, because Julia has been around for quite a while now, but we improved the implementation of the new capabilities. And so this is also something I want to show. So let's get right to it. And let's start with SQL. For SQL, we are introducing several new SQL evaluators. So the main entry point is just called SQL. It's an high-level evaluator that basically allows you to connect to, main vendor databases. Talking about relational databases, we are talking about PostgreSQL, MySQL, Microsoft SQL, SQLite, and Oracle as well. We are also supporting several dialects like MariaDB. That is a variant of MySQL. And you can connect on a localhost or, your hosted database, AWS, whatever. The other one is called SQL JDBC. So I'm not going to show it because for lack of time, the API is almost identical. It's actually identical. But just to know that if you have, working with database link in the past, or you have like an existing JDBC connection, you can use those in ExternalEvaluate, and they work. Another thing we're working on is SQLite. It's a performance-oriented evaluator for SQLite only, and this is going to be released probably at the end of the year, start of the new year with a Paglet update. So let's see how you can use it. The first thing you need to do is to have a database. So here I'm just downloading a database I found on the wild. Once the database is on your machine as a file, because SQLite it's just a file, you can register it. Now the registration step is optional. You really don't need to do it in terms of if you want to use it, but it is required if you want to use external cell. In case you have never used external cell, it's pretty easy to have one. You just put your cursor right in between a cell, and then you press Shift greater, and a new cell is coming out. Then from the drop down here, you select the language you want to use, and that's pretty much it. You write the command, and then you press Shift Enter like you would do usually. And so this query, it's a pretty simple one. It's only asking for all the tables that are inside the database, and the result is going back to you the data set. Another query that I'm doing right after is this one. I'm selecting the first 10 artists, and you see that there are 2 columns here: artist ID and name. Another query, I mean, even nothing special. I'm not here to write query, but what I'm doing here is a simple join And you can see that in the dataset that is coming back, the names of the column are the one that I'm specifying here with the S statement. So you can basically use the S statement in your SQL in order to name the columns in your dataset. So let's see how you can use it programmatically. In ExternalEvaluate, basically you need to specify the evaluator. In this case, is SQL. Then you can specify the target. The target is either a path to a file, in which case is SQLite, or otherwise it can be a URL, which allows you to specify other kinds of database. We'll see that later. What I want to show you here is the return type. The return type, because normally, by default, the return type is going to be a dataset, but you can return data in other shapes. So this is going to be the same query, first and artist of the database. The return type here is row. So you see that this is going to be just a list of lists where every inner list is going to be one row. So first artist is AC/DC, second artist accept, third artist Aerosmith, etc., etc. Otherwise, you can use named rows. This is going to return the same shape, meaning that it's always going to be row-oriented data. Only that inside a list, you're going to find an association where the keys are going to be the name of the columns. Otherwise, you can use columns. Columns is going to be a transposed data. And so it's still going to be list of lists, but every list is a whole column. So you see that we got a list with all the IDs and a list with all the names. Or you can do named column, and you're going to have an association where every key are the columns and the values are going to be the whole content of the column, like in this case. So you have a different shape to choose from according to whatever you need to do next. The other thing that you can, so previously I was working with SQLite. SQLite is a terrific database, like very fast. It's used almost everywhere nowadays. In our phone, it's, any kind of application is using SQLite. But SQLite got its limitation. For example, like the types that you can use are not that much. It's only strings. It's going to be binary data, integers, stuff like that. On the other hand, other databases have a much richer type system. For example, this is Postgres. I'm connecting to a Postgres instance on my machine on this port. This is the name of the database. And yeah, I mean, when I run this query, I get back directly date object because what I'm specifying here is that I want a day in a date. Granularity here is going to be a date object with granularity day. So no time information, no time zone information. On the other hand, if you do, for example, something like select now is going to return a date in the time zone of my database. So that you see that there is still set as time zone with my in Italy. And so you get back the time with the time zone of the database. In the query, you can obviously change that, but by default, this is what Postgres does. Another thing that you can do is to subtract two dates in Postgres, and when you do that, Postgres calls the result of this operation an interval, and for us is a quantity. So every interval is going to be converted into a quantity in seconds. Another thing that you can do in Postgres, which is really, really nice, is that, like in the past years, there's been a lot of traction with NoSQL database, and now suddenly they are kind of disappeared again, because what is going on is that traditional databases like Postgres, like MySQL, they started introducing NoSQL data in it, and we are adding support for that as well. So you can do a select and create an array, and you get back an array in Wolfram language. And that works as well for JSON data, key value structure that Postgres support is going to be an association with all kinds of non-relational data that you got. And yeah, that's I think that's pretty much it for SQL. as I was saying, unfortunately, we need to move quickly. Don't have much time. But yeah, feel free to ask more questions later or at the end. Another thing that I want to show is Shell. Shell is an evaluator that requires zero configuration on your side, because normally you already have a shell on your machine. So chances are that this is already working for you. All you need to do is to start, is to create an external evaluate cell by pressing shift grader. That will create a cell for you. We are supporting command.x and PowerShell on Windows, ZSH, SH, Bash for Mac and Linux. So once you have the command you want to run, you press shift enter, the command is coming out, the output is coming out in real time into the notebook. And the result is going to be either a success or a failure, depending on the exit code of the program. So whatever the program was returning, a success exit code or a failure exit code, is either be 0 or something other than 0. You're going to get a success or a failure. In terms of programmatic usage, again, you see same thing as before. You have a target that in this case is going to be the path to the shell. So by default is ZSH on Mac, but you want to use something else, you can do it. You run the command, output is coming out, and the expression is coming out. So I'm assigning now this success thing over a variable called R. And that object contains everything that happened during the execution of the program. So you can extract the standard output from it. You can extract the exit code or the standard error. Again, if you don't need all this stuff, you can directly specify a different return type. So different return type you can choose between, I don't know, the standard output if you care only about that. And so you see that now the return value is going to be a string. In case you can ask for the standard error, or you can ask only for the exit code if that's all you care about. And you see that in any case the output is coming out into the notebook as it comes. So another thing that you can do is to run templated commands. This is like a feature that is available framework-wide. So in your command, if you are using string template syntax, you are able to do evaluations. And the result of the evaluation is going to be substituted into the string. So in this case, for example, I'm echoing the path of my kernel. So basically, you can use globals or locals during the evaluation of the command in order to construct a command that takes input from whatever is the environment that you're running. So this is another feature that you can use. This can also be used in other languages. And yeah, one thing that I'm doing here, nothing too complicated. I'm doing something like continuous integration kind of things where I am downloading a program. I am cleaning up the environment, downloading the program, then I'm unzipping it, and I'm going into the directory to build the program using Cargo and Rust. It's just building an executable. If I run this guy, you see that the output again is coming out in real time, and this is all the things that it's doing is updating crates, downloading stuff, and then at the end the output is coming out. And this is the output of the program. The program is something very simple that is just hello world kind of stuff. It's printing current timestamp. You see that for every command I was running, I get back a list of everything that was happening inside all of these objects. The output of every command is there. You are probably interested only in the last one. And yeah, I mean, this is basically, automatic bunch of things that if you need to do it by hand with run process, you will need to, read things line by line. It's not really that complicated, but it's actually hard to get it right, especially if you need to deal with Unicode characters and things like that. So we are getting the encoding right and things like that. out of your, and yeah. So with shell, you can basically run any kind of program like you are in inside a terminal, but it's coming out inside the notebook. Yeah, I think this is also pretty much it for shell. And I can move on to Julia now. So the Julia integration has been improved. Like for everything we're doing with ExternalEvaluate, we start with a core implementation. We just, something that actually works. And then in time, we are adding more and more features. And what we have done here, we are including new type support and a support for multidimensional array that is actually generic for all the types we are supporting. And yeah, let's see what I'm talking about. Basically, you can start a session in Julia. You say that you want to use dates, and after you have done that, you can start to run commands. So this is basically an interval in Julia, an interval of time, 3 years or 10 milliseconds, and this is automatically converted for you as a quantity inside the Wolfram language. You can also, we're also supporting dates. Again, like a date without time information is going to be a date object with date granularity. Or you can have like a date object with time zone information. Again, if you subtract 2 dates, you're going to get back an interval. The interval is a quantity for us. And that's what you get. So you can receive dates. You can also now send dates to Julia, which is something you can do with an external function. So basically, external function allows you to, declare a function into the language and pass parameters that are actually, pass expressions. So what I'm doing here, just to show you that you are able to send data to Julia, is that I'm running a built-in function called rep. Rep is basically, when you print something in a terminal in Julia, rep is what is called to visualize it. So it's basically transforming the object into a string, and that's actually the output you see in the terminal if you're using a terminal. I'm using it because I want to show you that if I'm sending to this function a date object, this is what Julia sees. So it's actually a datetime with all the information about time zone and stuff. And again, if you are sending like a date object with date granularity, we are getting you should see just date object. We are also adding support for multidimensional array of any kind of size. The tricky part here was that basically we are a language where array are row-based, and Julia it's kind of different. They have all array are column-based. What does it mean? It means that this is how you create multidimensional array in Julia. You do reshape from 1 to 8, and then it's pretty similar to this command where you're doing array reshape. The only difference you see is that for us, the array is row-based. On the other hand, for them is column-based. It's easier to see if I show you the matrix form. And so you see that for us, arrays are first going on rows, and for them, they go on columns. And so this is actually tricky to get it right, but we are handling the correct transposition of data in order to, maintain the data in the same shape it was either on Julia or on the Wolfram language system, and everything now round trips quite well. What you do now is that, this implementation is also generic, meaning that if you are creating an array of complex number, you're getting back an array of complex number for us. And it works for all the types you have seen so far. So like for quantities or for dates, it's basically the same. Again, you can send array. I'm using the same trick as before, where basically I'm doing the rep of the function, and I can send like an array. And you see that in Julia, now you see an array of integer 64. In case you want to keep your memory footprint low and you need a different type of array, you can use numeric array. And if you are sending, for example, real 32, you should see float 32 in Julia, or unsigned integer 16, you see the corresponding type in Julia. Also sparse array are working, but you see the non-sparse version in Julia. So yeah, I mean, the implementation now it's allows you to do much more types, especially if you're working with like a lot of people do, time series and stuff like data exploration, what Julia is made for, data analysis. So that should make a lot of workflow easier. What else? We have talked about what we have done in the past, and now let's see what's going to be in the future. I'm very proud to announce that the whole framework is going to be open source, like very soon. The end of the year or starting of next year, it's going to be on GitHub. Obviously, we need to do a bunch of things before that happens, namely documentation, things like that. But we are getting there. And so the idea is that, you know, people will be able to contribute to existing implementation. They can, you know, bring their own favorite language to the framework if they want. And yeah, pretty excited to see what community and people will be able to do with it. Another thing that we are trying to do, namely for Python, because we want to be, you know, be able to run Python code much easier, make it easier for people to run Python code, is to do a Python runtime distribution. The problem, what is that right now, Python is not really easy to port. Like everything needs to be installed on one machine, and you know, if you have different version of Python, most of the time you have some tricky bugs that are happening between you know, one version and another. What we want to do is that we are releasing like a Python distribution, a whole interpreter that is downloadable as a Paglet, and it's gonna be, you know, the same Python installation on your machine is gonna be the same one on another client machine, and so you can have you know, a Python notebook, give it to another person, and you are sure that the other guy, if he's using like this distribution, he will be able to run you know, the very same Python interpreter that you have, and that should you see basically inside this Paglet now there is this is the path for the Python runtime, and I can simply use it in order to do evaluation. Obviously, there are other things to solve like dependencies and things like that. We're getting there, but this is one of the first milestones that we need to do in order to make sure that, you know, when you have a bunch of Python code on one machine and runs on another machine, the interpreter is the same. We also want to automate installation of dependencies, but that is a whole other chapter. In any case, yeah, I think it's everything for today. We covered a lot of grounds, but let me know what you think. And yeah, thank you. Any question?
You do quite a lot of special serializers and deserializers to transfer data. Python.
Yes.
Is it like a universal serializer framework?
No. No. It's basically, it depends from the language. We inside the implementation of every language, there is a serialization function and deserialization function. The easiest thing you can do is to start with something like JSON because it's widely adopted by any language. But for example, for Python, we wrote a serialization of expression that is using WXF, which is a binary format, which is much more performant. And in Julia as well, we are using a binary format to transfer data. But in general, it's just a function. So you can connect any kind of serialization. you want to exchange data.
So do you always use 0MQ to connect to the?
Not always, but yes. So for example, Shell is using only, so by default, we are making that our, easiest path. But you can communicate in other ways. So for example, Shell is communicating with standard in and standard out, not 0MQ.
So how many 0MQ connections you can say a Python session?
Yeah, one. Client-server communication.
Say Jupyter maintains 6, right?
Yes, yes, because they also have the ability of stopping. Yeah, they're transferring several more things.
Really, really interested, as you say, but the framework can be developed in a new language. I've been trying to add a new language, but it's not. It's not as stable as the existing Python. That is, but I need to make my own cell, like small cell, and ideally with the external evaluate, I could just say, okay, use this icon for this language and put it in this.
You can try to see it during the workshop if you want. Yeah. Which one, sorry? Ah, it's a serialization format. What is that? Like Apache? No, Dash?
For massive data sets.
Yeah.
Massive data. So you don't have to move a massive data set into Wolfram. You ask pointer and it happens instantly.
Yeah. I am not sure if we are doing zero memory copy, for example, in Python. But yeah, I mean, those are all optimization that we are not using that one, but we are using our internal WXF format in order to exchange data, which is more efficient for expressions. But it could be done in theory.
Well, your Python, maybe I'm talking bullshit, but your Python connector has an extension class, right? So you can write an extension that just recognizes this serializer and does something special.
Yes. Yes, in theory it can be changed. I mean, once it's open source, you can fork it and bring your own different implementation. I need to stop, but okay, if it's last one. Well, internally it's using run process. It's not really replacing it, because run process allows you to start a process and keep it running on the background, while this thing will basically lock the kernel if you're doing it. So it's not really it's not really the same thing. Okay, anything else? We can discuss it later during the workshop. Thank you, everyone.